In this lesson, we'll begin looking at chemical bonding, which is how atoms join together. Specifically, we will focus on the parts of an atom that interact to allow bonding to occur, the valence electrons. To begin, let's quickly review atomic structure. Let's say it's a summer night and you are home waiting for a pizza or a friend to arrive. You turn on the outside light, and almost as soon as you do, you know what's going to happen, right? Bugs are drawn to the light and start hanging around it, but they don't just stop and stay in one place, do they? They swarm around the light, flying or orbiting around it, kind of forming a bug cloud around the light. You can think of the light in the center of the cloud as representing the nucleus of an atom. Recall from basic atomic structure that the nucleus is the center part of an atom where protons and neutrons hang out. That leaves the electrons. Electrons always orbit around the nucleus, staying in constant motion and forming an electron cloud around the nucleus, much like the bug cloud that formed around the light in our demonstration. Here we see one atom, represented by the light as the nucleus, and the bug cloud is the electron cloud. But chemical bonding only occurs when two or more atoms interact with each other. To see how atoms interact to form a chemical bond, we need another atom. So let's add another light and wait for more bugs, or should I say electrons, to show up. Our picture is getting rather crowded though, so let's get rid of the stuff that doesn't matter for chemical bonding. We can even get rid of the lights themselves, representing the nuclei of the atoms, because neither the protons nor the neutrons participate in chemical bonding. We just need to look at the electron clouds. Within these clouds, and again rather like the bugs around a light, some of the electrons orbit very close to the nucleus, while others stay a little farther out. These different areas represent different electron shells or orbitals. In this image, each atom has two orbitals. Looking at this image, what part of the atoms do you think are most likely to interact if the atoms move close together? It's going to be the outermost parts, right? That means the electrons in the two atoms' outermost orbitals are most likely to interact. Those outermost electrons are called the valence electrons. Only the valence electrons interact, and they alone are responsible for chemical bonding. The valence electrons also determine an atom's stability and chemical reactivity. An atom is stable and thus less likely to interact with another atom to form a chemical bond if it has a full outermost electron orbital. Let's look at an atom. Recall that the first orbital, the one closest to the nucleus, can hold only two electrons. It is unstable when there is only one electron, but becomes stable when there are two electrons. Most atoms have more than one orbital though, and by the octet rule, they are stable when the outermost orbital has 8 electrons. The outermost orbital never holds more than 8 electrons. As we see here, atoms that do not have full outermost orbitals are not stable. Once the outermost orbital is full, with 8 electrons though, the atom becomes stable. Not that atoms have emotions, but if they did, they would want a full outermost orbital so they would be stable. And that desire, so to speak, to be stable is what leads them to react with other atoms. Atoms react with other atoms to try to become stable, and this is the basis of chemical bonding. Let's look at a couple of ways that they do this. Here we see two unstable atoms. Neither has a full outermost orbital. In ionic bonding, atoms gain stability by actually gaining or losing electrons to attain a full outermost orbital. Atoms that join by ionic bonding form compounds. A classic example of an ionic compound is sodium chloride, which you know as salt. In covalent bonding, atoms share electrons, so they both can claim to have a full outermost shell. Atoms joined by covalent bonding form molecules. For example, atoms of oxygen join to form molecules of oxygen, which you are breathing right now. We will look at these two types of chemical bonding more closely in other lessons. Atoms join by chemical bonding to form molecules and compounds. These molecules and compounds can be as small as 2 atoms, such as oxygen molecules, or be made of millions of atoms joined together, such as in DNA. All of our body parts, from the parts of our cells through whole organ systems, are built out of molecules and compounds, and all the functions that these structures perform to keep us living require interactions between atoms and the making and breaking of chemical bonds.